What's up, geeks, and welcome to the channel.
Java's Future API was introduced in Java 5, and the future is used as a reference to the result of an asynchronous computation. We previously explained and gave a lot of examples related to multi-threaded operations in Java, and today we're going to further expand on this topic by tackling Completable Futures, which were introduced in Java 8, and their main purpose was to handle the limitations of the future class. So what's a Completable Future? The Completable Future class, just like the future one, is used for asynchronous programming in Java. Asynchronous programming is a means of writing non-blocking code by running a task on a separate thread rather than the main application thread. This way, the main thread won't have to wait for the completion of this async task and can execute other tasks in parallel, improving the overall performance of our program. At the beginning of the video, we mentioned that the Completable Future class was created to handle the limitations of the future class. But what are these limitations? Let's say we wrote a method that retrieves a certain piece of data from a remote server, and since this call is time-consuming, we chose to run it in a separate thread and return a future. Now, let's say that the remote service is down, and we want to complete the future manually using the latest cached version of the data available. Can we do this with future? No, we can't. Also, futures cannot perform further action until the result is available, and it doesn't notify us of its completion. It provides a get method which blocks until the result is available. Moreover, we don't have the ability to attach a callback function to the future and have it get called automatically when the future's result is available. The next limitation is that multiple futures cannot be chained together. You see, sometimes we'll need to execute a long-running task, and when that task is done, we need to send its result to another long-running task, and so on. We cannot create such an asynchronous workflow with futures. Additionally, multiple futures cannot be combined together. So, say that we have 10 different futures that we want to run in parallel, and then run some function after all of them complete. We can't do this with the future class either. Finally, there is no exception handling in the future API. So many limitations, right? Well, that's why we have Completable Future. Everything we just discussed can be achieved with the Completable Future class. Completable Future implements the future and the completion stage interfaces and provides a huge set of methods for creating, chaining, and combining multiple futures. It also has a very comprehensive exception handling support. Okay, let's start by creating an instance of this class with no args constructor to represent some future result. All the clients who want to retrieve the result of this completable future can call the get method, which blocks until the future is complete. So here our call will block forever because this future is never completed. To manually complete this future, we can use the complete method as you can see. All the clients waiting for this future will get the specified result, and subsequent calls to the complete method will be ignored. Additionally, to avoid blocking our thread while waiting for the result of the get method, we can make use of the getNow method, which returns a default value if the result is not ready. This will not consider the future as completed. Now, what if we want to simply execute some code asynchronously? The static methods runAsync and supplyAsync allow us to create a completable future instance out of the runnable and supplier functional types respectively. Both runnable and supplier are functional interfaces that allow passing their instances as lambda expressions. So, to run some background tasks asynchronously without returning anything from the task, use CompletableFuture.runAsync. It takes a runnable object and returns a completable future void. On the other hand, if we want to return some result from the background task, we'll make use of the supplyAsync, which allows us to provide an instance of the supplier as a lambda expression that does the calculation and returns the result, as you can see in the example in front of you. Now, notice how the CompletableFuture.get method is blocking. It waits until the future is completed and returns the result after its completion. But that's not what we want, right? For building asynchronous systems, we should be able to attach a callback to the completable future, which should automatically get called when the future completes. This will be made possible with the help of the thenApply, thenAccept, and thenRun methods. The thenApply method takes in a function, so it will accept and transform the result of the completable future when it arrives, and will produce another result, which can be further chained to multiple thenApply methods. On the other hand, the then except and then run method are usually used as the last callback in a callback chain as they do not return any result. The then except method takes in a consumer, so it will accept the result of the previous future and will return void. However, the then run method doesn't even have access to that previous future result. It simply takes in a runnable and will execute it when the previous future is completed. Notice in the outputs of our previous chained calls that no matter how many callbacks we attach on the same future, all these callbacks will be executed in the same thread. To execute our callbacks in a thread different than the one used by the future, we can use the async variant of these methods, as in the then apply async, then accept async, and then return async, as you can see in front of you. Okay, now let's say we want to fetch a bank account object from a remote service, and once the account is available, we'd want to fetch the balance of that account from another service. So consider the implementations you see of getBankAccount and getAccountBalance methods. Let's understand what will happen if we use thenApply to achieve the desired result. In earlier examples, the callback would return a simple value, but in this case it is returning a completable future. Therefore, the final result in the above case is a nested completable future. If you want the final result to be a top-level future, use the thenCompose method instead. So, quick recap. If your callback function returns a completable future and you want a flattened result from the completable future chain, which in most cases you would, then use thenCompose. Okay, while thenCompose is used to combine two futures where one future is dependent on the other, thenCombine is used when you want two futures to run independently and do something after both are complete. The callback function passed to thenCombine will be called when both the futures are complete. A simpler case is when we want to do something with two futures results, but don't need to pass any resulting value down a future chain, meaning you don't need the return type to be a completable future. Then the thenAcceptBoth method is there to help. Now, if we want to execute multiple futures in parallel, wait for all of them to execute and then process their combined results, then the CompletableFuture.allOff static method does the job. The limitation of this method is that it does not return the combined results of all futures. Instead, we have to manually retrieve the results from the futures. Fortunately, CompletableFuture.join method and Java's Stream API make this operation very simple. On the other hand, CompletableFuture.anyOff, as the name suggests, returns a new completed completable future when any of the given futures completes. In the example you see, since the third future has the least amount of sleep time, it will complete first, and the final result will be Geekific. The problem with anyOff is that if you have completable futures that return results of different types, then you won't know the type of your final completable future. Okay, we explored how to create completable futures, transform them, and combine multiple completable futures. Now let's understand what to do when anything goes wrong. And to do that, let's first understand how errors are propagated in a callback chain. So consider the following completable future callback chain. If an error occurs in the original supply async task, then none of the thenApply callbacks will be called, and the future will be resolved with the exception occurred. In other words, the exception will be thrown, and so on. Meaning that if an error occurs in the first thenApply callback, then the second and third callbacks won't be called and the exception will be thrown. The exceptionally callback gives you a chance to recover from errors generated from the original future. You can log the exception here and return a default value. Note that the error will not be propagated further in the callback chain if you handle it once. The API also provides a more generic method, the handle method, to recover from exceptions. It is called whether or not an exception occurs. If an exception occurs in this example, then the result argument will be null. Otherwise, the exception argument will be null. So, that's it for this video. I hope it was helpful. Thank you guys for watching. Take care, and I will see you in the next one.